you might be asking yourself, when would I need to sketch a function by hand? Now, while it's true that you could just use your graphing calculator, or you could just pull up Desmos, it's not always the case that you have access to those. For example, you're in class taking a quiz or test and calculators aren't allowed. So let's go ahead and take a look at a common calculus problem that would require us to sketch a couple functions. What we're asked to do here is to find the area bounded by these functions given f and g. What we'll do is we'll go ahead and make a quick sketch of the graph to understand the region that they're asking for. Let's start with g of x, which is just a line with slope 1 and y-intercept 1. Now, to graph f of x, we should notice that this is a parabola. The x squared is positive, which means it has a u-shape upward. So it should look something like this, but I don't exactly know where on the graph it should go. So what I'm going to try and do is factor f of x so that I can get an idea of where the x-intercepts are. What this means is that -1 and 3 are x-intercepts. We'll go ahead and label those here. And then we'll just go ahead and sketch our u-shape. Awesome, we have the graphs. Now this is the area that we want to find, but what we notice is that it's bounded here and here. What are those boundary points? Well, these boundary points or intersection points occur when these two functions are set equal to one another. So we'll go ahead and set those two equations equal, move everything to one side, factor, and what we find is that x is -1 or x equals 4. Those are the points where these intersections occur. I already knew the -1 made sense. Here, we're just going to label this that occurs at x equals 4. Now, to wrap up that problem, it would require us to have some knowledge of integrals, but hopefully you can see the importance of that sketch.